So next question is, again, you have these two charges. The configuration is given as the charges are 2.2 meters apart from each other. We have also this coordinate system that is x and that is y. And q1 is located on the x-axis away from the origin 1.4 meters. So the question is saying that if you put a proton just midway between two charges, let's this be the proton
Hocam bu
between
arada kaydetmiyorsunuz sanırım dersin.
two charges. I'm recording it on another program. So if this q is proton is between these two charges, obviously the proton will experience a force acting on it. Because of this force, the proton will accelerate and find this acceleration. That's the question. Okay, when you release the proton over here, what is the acceleration initially? Of course, as it starts accelerating, of course it will just change its location, and whenever the change in the location happens, the force will change. When the force will change, the acceleration will change. So this is going to be a type of motion which changing acceleration. But the question is, what is the initial acceleration of the proton? So, well, the method is straightforward. What you do is just find the force of attraction or repulsion, whatever the force on this proton because of Q2 and because of Q1. Find the resultant force, and then this force is going to be mass of the proton multiplied by the acceleration. From that, you will find, you're going to use this expression m times a, and a is going to be f divided by m. But what is f on the proton? And the proton mass is, I think it's 9.1 times 10 to minus 31. No, that was electrons. But the protons is just 1,800 multiplied by the mass of the electron. Anyway, okay, so let's find this force. Force is, since Q2 is positive, Q2 will push the proton down. And since Q1 is, let's name this force to be F2, because Q2 is, let's put the force F2, the force applied by Q2 on the proton, and this is proton. And what about Q1? Q1 is, since Q1 is negative, Q1 is pulling the proton onto itself. So again, it will produce a force which is again downward. And let's call this one F1. And both forces are in the same direction, so we have to add these forces to find the resultant force, F1 plus F2. Well, F1 is, what is the distance between the charges Q1 and Q2 to the proton? Is 1.1. And K times, let's find first Q2 force, F1 force. Q1 multiplied by the charge of proton, which is a charge of electron. Well, we always take absolute value of this multiplication because we know the direction of the force. So we only need to know its magnitude divided by 1.1 squared. So the force 1 is 9 times 10 to 9. Q1 is 1 microcoulomb, absolute value. It means 10 to minus 6 multiplied by the proton or proton charge is electron charge, 1.6 times 10 to minus 19 divided by 1.1 squared. This is F1 magnitude. F2 is going to be K times Q2 multiplied by E again, 1.1 squared. So 9 times 10 to 9, but this time Q2 is 2 times 10 to minus 6 multiplied by proton charge 1.6 times 10 to minus 19 divided by 1.1 squared. This is F2. So you calculate all these and add them to find the acceleration F1 plus F2 divided by mass of the proton. Mass of the proton, as I said, it's I think 1 1800 multiplied by the mass of the proton, 9.1 times 10 to minus 13, 1 kilogram. Just check it, okay? Mass of the proton. So put all these numbers over here to calculate the acceleration. That's it. This is the answer to the question.